By this point, you surely know LLMs are models that run on computers. Now, there's a new type of model in town where people have described this as AI that can think before it speaks. Well, what does this mean? In this video, we're going to dive into reasoning models. Reasoning models are new types of models. Traditional large language models generate responses immediately. They have a bias towards answering without thinking, and they're fast, but sometimes can miss complex problems. A new type of model that is a reasoning model or a thinking model now can think step by step before answering. It can show its work, like solving a math problem, and it can also catch and even correct its own mistakes. For example, when we look at a reasoning model by OpenAI, we have three different components that are thought to go into training this model. The first one is called chain of thought. Chain of thought was an early prompting technique where you would tell a model to think step by step. This thinking step by step was an early trick to get a regular, old-fashioned ChatGPT 3 or 3.5 type model to think logically step by step and return an answer that showed its thinking step by step. This is called chain of thought. And this chain of thought prompting was an early strategy to try to coax good responses out of the model. Because if you have a model that is explaining each step along the way, let's say that you have a problem that is 3 consecutive math problems. Now, we all know that large language models are terrible at math, but work with me here. So if we said in the first step you need to add 2 numbers, and then in the next step you needed to multiply a number, and in the final step you needed to square that number. If you told the model to do this all in one shot, it might get this wrong. But if you had a chain of thought and you said think through step by step, then the model would think through step 1, return an internal response. It would think through step 2 and would get through step 2 and finally through that third step and then return its response. And the response that it would give you is each of these steps that allow you to check its work. This chain of thought prompting now happens inside of the model. These models have been trained on chain of thought prompting. Second, there's also a step of self-reflection where the model is going to be prompted to review and improve its own answers. Now, this is not your prompting. This is trained within the model. So if the model then knows at the end of the response or at the end of the reasoning phase, it needs to review its response before it provides it back to the user, then it's going to make sure that that response passes some internal validation and checks. Now, what does that look like? Well, these models are black box, so we don't totally know what it looks like. But self-reflection, where reviewing and improving an answer, allows a model to return more thoughtful responses. And then finally, this third approach is through multiple attempts. So it tries different approaches to problems. Now, we know that another large language model provider called Anthropic makes a model that's called Claude. And Claude is a toggle that you can toggle thinking on and off, which, if we pause for a second, is a really hilarious thought where we can turn off and on thinking. Anyhow, when we turn thinking on, we know that Claude does something unique under the hood. Claude is going to turn its temperature all the way to 1. So if you remember all the way back to the first video when we were talking about how these models work, temperature is another word for creativity, which is another word for probabilistic sampling. And we are going to then set the probability quite low or quite high for the likelihood of the next response. So when we turn up the creativity or turn up the temperature, what we're going to do is we're going to start sampling probabilistic space of words and thoughts that are less likely. So when you toggle on thinking in Claude, you are going to be sampling less likely probabilistic space. So if you now think of this sampling process, and you have a path of one of 2 roads that leads to the top of the mountain, you're not sure if either of those roads are going to get there or not. But if you have a path of 10 roads, and you could take these simultaneously, you could then ensure that one of these is going to be the best way to get to the top of the mountain. This multiple attempt all happens internally, and this is exactly what these reasoning models are doing, is they are increasing the attempts, they're increasing the probabilistic sampling space of the most likely response to what the user has provided. and then are going to do those attempts before returning the answer. So these models then are working internally. These reasoning models are then working in order to try to do this thinking process, this chain of thought, self-reflect on the answer, try multiple approaches in order to come up with the best response. So as one example, I prompted the LLM. I said, what is a good example of a problem that demonstrates O3, which is one of OpenAI's reasoning models, thinking capabilities compared to other ChatGPT models? So you can see that the OpenAI model came up with two possible responses. Two classics, such as the 12-coin counterfeit puzzle. So you've got 12 coins, so the puzzle goes. One of them is counterfeit, and it either weighs more or less than the rest of the 11 coins. In exactly 3 tries, you need to come up with an approach to weigh these. You have a balance that is essentially a balance to weigh these on each side. You have a balance that is going to then can be used 3 times, and you have to come up with the coin that is counterfeit and if it weighs more or less. Okay, so here is a reasoning logic puzzle. What you could do is you could start going through it in your mind. All right, so if I take 6 and 6, one is going to be heavier, one is going to be lighter. Okay, now I know the counterfeit is in one of those, but I don't know exactly which one yet. So then if I took one of those and I put it and I said 3 and 3, if those are the same, then I could go through and I could check the other 3 and 3. And I start going through these permutations. I quickly realize that if I split it by 6 and 6 at the beginning, I run out of tries. The constraint is I only have 3 tries in order to determine the counterfeit coin. So I need to come up with a different strategy. This is exactly what the LLM is going to do. It's going to have multiple attempts. It's going to work through its reasoning to try to come up with this logic. Now, another example is Einstein's 5-house puzzle. In these puzzles, you have 5 houses with 5 different people that have 5 different drinks and 5 different pets and so on. And your task is to take a series of clues and apply that to this puzzle to determine who lives in which house with which pet and which favorite drink and so on. Now, this is an example that these reasoning models work well with because you have to hold several parameters or several variables in your mind at a time. And so as you work through this logically, you need to keep track of the permutations of who lives where and has what pet and so on. So this is where, when you've got several different parameters, several different variables to keep track of, where these models have been specifically designed for this reasoning purposes, that's where they really shine. So some of these current reasoning models include the OpenAI's O models, O3, O4, O4 Mini, and so on. Claude 3.5, Sonnet, and Opus have this thinking toggle. Gemini with think mode. All of these models can be used to show this internal reasoning for complex problem solving. Now, there are a few trade-offs. For example, these models are slower because, again, they have to show their work and they have to check their work and they have to take multiple paths. They're more expensive because it's more compute. But despite these trade-offs, they are much better at these complex tasks. So the bottom line is you can go from instant answers to thoughtful responses. It's like the difference between gut reactions and careful analysis. So as you think through some of your needs and you have deep reasoning, logic type problems, go ahead and try some of these reasoning models. So for example, O3 and O4 or O4 Mini are OpenAI's version of mathematical reasoning or lightweight reasoning models. So the last key here is reason before you speak. Reasoning models are going to sample this low probabilistic space. They're going to evaluate answers before returning a response.